Well, before we get started, I want to tell the story about how we came up with this talk. Last year, in March, Chris and I had dinner, and after a few drinks, I think, we said we must collaborate together because we've been involved in the patterns community for a long time, but we'd never written papers together. And all we did that evening was come up with a title. And then we wrote a patterns essay for this year's. And from that, we had a lot of fun putting together this talk. So let's get started. So this is a picture of an elephant I took at the Portland Zoo where I live. So Chris, what patterns do you see?
I see a lot of patterns in this picture, actually. For example, there are the tracks of a car. There's some steps of an animal. There's texture on the wall. There's the grass, a recurrent structure. And of course, well, there's not only an elephant in the room, there's also an elephant on that picture. And I think the elephant is, for me, the most interesting pattern on this slide because it's something that is complex, interesting, and alive.
Okay. Do you know what an elephant is?
Well, I think I do. Who in the audience knows what an elephant is?
Do you know what elephants are?
Oh,
okay.
That's good.
Okay, so let's have a test here.
It's easy.
What's his color?
It's gray.
What's his natural environment?
They usually live in the savannah.
And how much food does he need?
About 150 kilograms, which is about the weight of us together. And fortunately, they don't eat any humans, just vegetarians.
And how do you interact with elephants in the wild?
Well, what?
Okay.
Oh. In the wild? You mean when I...
Not in the zoo, yeah.
Well, I'm not sure about that. So I know that elephants, they like fruits, so maybe I give them a fruit. But I'm not quite sure, because actually, I know they're friendly animals, but should I go away? Should I stand still? Can I look them in the eyes? And maybe it depends on the mood, so I don't know how to react. So maybe I don't know that much about elephants. And that is actually what we're going to talk about today. So the title is Elephants, Patterns, and Heuristics. And well, we all think we know elephants, but actually there's so many things we don't know about them. And that is similar to the patterns we talk about. So elephants are actually patterns also, but in nature. And we talk about patterns in design. And we think very often we know what these patterns are, but there's so much more to learn. And using methods from science, for example, observation, we can apply these methods also to learn more about the patterns.
So, knowing elephants, one of the things that we want to talk about is how can we know elephants? How do we shape our mental images of elephants? How can we best represent or try to represent elephants if we're not just next to one? How can we learn more about elephants? Why do we need heuristics? One of my favorite topics to get along with elephants, because it's not, how much can we know?
Yeah, so we want to know more about elephants. Actually, we want to know more about the patterns. So if you replace elephants everywhere with design patterns, that makes more sense what we're talking about today.
So, I guess say, Chris, do you know what a pattern is?
I know. I hopefully know what a pattern is. And I think most people in the audience also know what a pattern is. So you have used patterns before, probably. They've been around for more than 15 years in the DDD community, more than 30 years actually in software design. But where it actually comes from, we owe it to that person, Christopher Alexander, who is an architect and design theorist. And he and his colleagues, they have, in 1977, published a book, A Pattern Language. And this book was meant to enable ordinary people to express how they want to shape their environments, their cities. So there are 253 patterns in it about, well, how to shape your neighborhood with shopping, streets, and raised boardwalks, and also how you build your constructions with different ceiling heights. All these kind of things are in there. And what the core definition of what a pattern is, according to Christopher Alexander, is it is a generic solution, so something that you can apply again and again, but in different ways there's variation. And it's not a one-time solution, it's something for a recurrent problem that has to fit to a specific context.
So our pattern descriptions that we in the software world tried to do, and that's different than a pattern in the world, our descriptions try to describe what that thing is in the world. And in general, one of the things that's nice about pattern descriptions is if the pattern author that tried to describe it talks about where did they find this, then we kind of know where it might live happily, and what is it trying to solve, and some idea about the solution of how it usually works. So pattern descriptions, as opposed to patterns, are kind of useful.
Okay, talking about solutions. Solutions are not only what we can see, the solution, but also how we build them. So Christopher Alexander has given many definitions actually of what patterns are. And one of the important ones is this one, where it says patterns are both a process and a thing. So the thing we build, but also the process how we build it, a plan. So it's not copy and paste, taking an existing solution, it is generating a new solution.
So as a designer, I have to do something. I have to take steps. I just can't make this. I have to follow a recipe? No.
Not a recipe. You have to make your own judgment in the process of making.
So, okay, I have to use my own judgment in the process of making, which leads me to one of my favorite topics, is like, what's a heuristic? So I've been inspired recently, and some of you know I'm trying to infect the rest of you about this, about heuristics. And Billy von Kohn wrote this book, his book, about how to end discussion of the method as sort of an engineering philosophy book. And he talks about heuristics as, and he was, by the way, he's a retired nuclear physics professor, and he used to build nuclear reactors. So this is interesting to know what he says. A pattern, in his definition, is anything that can work, but it's not guaranteed. It's a direction towards where we want to get, where we envision the world. But we can't really justify it, and it's not always going to work. So he also talks about 3 different types of heuristics, which I think is interesting to think about. Our attitude or beliefs, our values. So in the DDD community, you know, my heuristic about the language that we speak should match the model in the world that we have perceived is an attitude or belief that drives your use of other heuristics. And then the actions we can take, like our software patterns are like that. And then heuristics that guide our choice of other heuristics. So for example, if I'm going down a tangled path, what should I do? And then if I discover where I am, then what might I do next?
Heuristics is, well, it's an interesting term, but it's also a little bit weird or academic. So what does it really mean?
Academic or obscure, yes. I've found people, now after 2 or 3 years, people in this community who've heard me talk can now say the word heuristic, pronounce it correctly. But it is a strange word when you first hear about it. So in the English language, synonyms for heuristic are interesting to think about. Rules of thumb. So for example, I might try this. It might work. Some intuition. Some might be really just, I think we should do this because I think it might work. There might be techniques that we have. There might be rules of craft, like this is the way we think about things here.
Well, so there's also a German word for that, and that is Faustregel. I'm not pronouncing the Dutch one, but I translate that. Faustregel means it's rule of fist, actually, not rule of thumb, rule of fist. So
yeah, when I first heard that, I thought, that sounds more forceful. You must be more certain.
And I was thinking maybe we're just less precise. Sorry.
Okay, so back to elephants, because this talk is also about elephants as well. Chris, you said what color?
I still think that they're gray. See?
Whoops. Okay, so here's
Yeah, brownish gray. They're gray.
you're right, and we saw this one at my zoo. Yeah. Okay. All right. Bathing elephants. They're kind of gray. And there's mud bathing and red elephants. Dusty elk.
Yeah, I know.
What colors?
You're tricking us here. But they're still gray. So there's a masquerade on that. They appear different now, but they're still gray elephants.
All right. Here's an Asian elephant.
We've seen an Asian elephant with red sprinkles before.
Spots.
Yeah, spots.
Anybody see?
I wasn't aware of that they exist. So that's also, well, I have this image of gray elephants, but it's not exact. So it's like black swans. You don't see them often, but they exist.
So Rudolf Arnheim, who's someone who's inspired me, he talked about visual thinking. It says, the more perfect our direct experience is, even if it's limited, we can be caught into illusions, right? So what we think we see and then know is maybe limited by our field of vision and what we've seen. So just beware, okay?
So I think ever since we started writing the paper, we learned a lot about elephants.
We've learned, we know elephants, no, not really, do we? So here's the test. Where do elephants live, So what do you know about elephants there?
They live in the savannah, as I said. They live sometimes in the zoo. They also live sometimes in art. So there's this strange elephant standing on its head. They live in our fantasy. So there are many places where they can live. And also, how do they live, right? So they like to play. There are some romantic images of elephants. There's also, they like to play with other animals, kidding around.
Is that zebra getting a bath or something?
Yeah. And they are very social. They like to live in herds.
Okay, so we know a little bit. So here's the elephant at the zoo. What do you think is going to happen? Anybody have any idea what's going to happen to this elephant?
So if you look closely, the elephant is smiling. So probably he's making some jokes with the visitors.
Oh, they're over in the corner there. But actually, and he's approaching them. But then I found when I walked down that it was actually going to the timed feeder because they were timed feeding. I did not know that until I walked down there. So why do you think there's a timed feeder?
Well, I think maybe because they're not in the natural environment, so they might get too much food. So they just get
that's true.
sometimes of the day because they have this. They have to be on a diet, so don't eat too much.
Or maybe I was at the zoo for an hour, and maybe if they ate all their food all at once, then I might not see them eat. So I can get, yeah.
We're just speculating, and that's the point. We just have, we think we know what an elephant is, but we don't, there are many things we don't know about elephants.
So back to design, okay?
Yeah.
Okay.
So how does that relate to design? So I will ask another question. Who of you knows what a model view controller is? Oh, still very confident. That's good. That's a good question to ask people who are new to programming. And yes, so I'm also teaching at a university, and if I ask my students, they all raise their hands. They know what a model view controller is.
Even before they come to your class?
And even before they know what patterns are. But if you ask them, what is an MVC? They say, well, it's a separation of concern. There's this business logic and the model. There's the views. There's the controllers. Okay. And how do you implement them? Well, we put them into different folders, because that's what most frameworks do. Good. And how do we make sure that the model doesn't have to know which views exist? Well, they don't not only know how to do that, they're not even aware why that is a problem. So, because we know when we program which views exist, so
it's in that
the
folder.
model can do that.
Yeah.
That's fine. So that is actually one of them. And if you ask them, well, why not use an observer to solve that problem? Well, what's an observer?
Okay. So how many of you know observers? Right. And
That's good.
And you think you know what they look like? Okay, we're inducing uncertainty, which is great. So the point is, once you have seen this primal representation, this thing that's imprinted into your brain, whether you've been misled or not, then you can recognize it elsewhere, even if it's different, superficial differences. So you have to be imprinted on this perception. So let's see what observer, the primal representation that I first learned about. Yeah?
So that's the one taken from the Gang of Four book, the original one. I don't know whether they changed it in your edition, but that's the one in the edition that I have. So what we see is there's a subject, and there's a concrete subject, and the observer can just register with the subject. So there's an interface so that the subject doesn't have to know what the concrete observers look like. And there's also some pseudocode that is important that tells you what there's going on. So this is actually maybe, or maybe not, we will discuss that, a good way to show what an observer is doing.
So Lisa, it's a physical structure I can see, right? If I knew what that was. It's not UML, by the way. It's proto-UML. Okay.
So if you go out into the wild, you will see different implementations. So a common example where you use it is to create graphic user interfaces. It looks quite similar to what we were seeing before, but there are different things. Well, some graphic user interfaces, like text components. You register the listener, and well, then you get notified when there's something going on. Somebody's pressing the button, or somebody's typing in some text. Another example is, well, if you have sensors, there might be different devices that are observing how the temperature is changing. It looks different still in this case because we have two different subclasses in this diagram. But it is, once you understand what an observer is, you can see, hopefully, this is also a proper observer.
So that primal shape still is there, but it's kind of mutated with this extra classes and, okay, all right.
So back to the original drawing from the Gang of Four book. And we were wondering, well, what do novice programmers do when they look up the observer? They go to Google. What does Google? Google brings them to Wikipedia. The first entry is not Stack Overflow, it's Wikipedia. So this is what it looks like on Wikipedia, the English version.
What do you think?
Looks a little bit different. The observer is on the other side of the diagram now, on the left-hand side. Doesn't make sense, so we can still see it's the same structure. But at the same time, it's also a simplification. They left out some stuff here. Actually, for first-time exposure, actually, that's a good way. This is almost the way I would draw it on a napkin.
Well, except for some of those little lines there between there, since
Yes.
you're not a UML geek and I am, you asked me about that. Oh,
Yes.
why are they there? And
Yes.
I go, there's a real meaning for that.
What is
We
the
won't
meaning?
talk about. Do you really want to know? That I'm not specifying any attributes. There may be some, but I'm leaving it unspecified.
But the interesting thing is, if we go back to the original one, you see that there is actually, it says this is the subject state. So it seems to be important because if there's not a subject state, why have an observer? You're observing the subject state, so it might be interesting. So leaving that out, I'm not so sure about that.
It's just not specified, but it's left out. But yeah, maybe a little confusing. Okay.
So, well, it was simplified. Let's go to the German entry of that, because Germans are more precise. Of course, we see there's more stuff on it. I know you can't, not all of you can understand German, so I retranslated.
Please, thank you.
I retranslated the German into English. And maybe you spotted on the last slide, I spoiled it already. There's some, in our views, there are some mistakes in this one. Do you see what is wrong there? There's some stuff that doesn't make sense. The same thing? Well, there's some differences, and there actually, some stuff is going on there. Well, they're back to the, actually, like it is in the original Eric Gamma et al. Book, Gang of Four book.
So they switched sides, but there's something else. But anyway, okay, let's...
Okay, so they also, well, they want to be more precise here, but they also get rid of the subject state for some reason. And they also, in the notify method, they provide an observer as a parameter, which I think is a copy and paste error when somebody was doing that diagram, because well,
What?
you register, unregister observers, but the core idea of the observer pattern is that the subject shouldn't know anything about the observers, so there should be not special treatment about that.
That one is the one that...
And the other thing is, well, if you have a superclass that does the register unregister mechanism, you don't want to override that in the subclass. It doesn't make sense. Unless you are a Java programmer and you don't have a class, but just an interface. But in the actual, in the original one, it was a abstract class where you can have a partial implementation, and so it looks different here. And the question is, I mean, this has been on Wikipedia, the German one, for
How many years? Yeah.
more than 4 years. So students go there, they learn this one, and they might be confused.
I told Chris after we had prepared this talk that he needs to go fix it. What do you think? Yeah.
I will,
Yeah?
and then we'll get
Fix
undo
back.
it again. But the point is, well,
Yeah.
the thing is, we have some expertise. Many people raise their hands here. They know what an observer is, so we can spot what is wrong there. But if you're just learning about that, you can't spot that.
Yeah. So it's kind of the case that I was picking at UML things and, well, what's this parameter here? If you were to ask someone who is experienced, who has deeper knowing about something, to draw what they see or explain what they see, the copies of a novice and an expert are very different, because the expert will focus on the important aspects and create quite a different representation of that. And so what we've had happen in the wild here is that the original observer was drawn in some way, and it got copied and copied and copied by maybe not experts, and it's out there in the wild. It's kind of a scary thought.
But we can understand that, well, as experts we see it's an observer in all of these cases. But the question is still, how do we create this thing? Or in general, how do we create a solution? And, well, to give that answer, we're using for some years now a metaphor of a path. So this is a map of a territory. And you can think of that territory as the context, the environment. And in that environment, you may be starting at some certain position and you have a goal. But there's a problem. There's actually a steep wall, and you cannot just go there directly. Without the steep wall, there wouldn't be a problem. You just go there. But with that problem, you have to do something. And it's not easy. You just can't walk around it. You have to find out, well, what is a good way? And there's actually a certain set of forces, limitations, requirements. And in this case, there's a canyon, there's some walls that you have to take care of. There might be a lake where you cannot go. So there's actually all these forces of that context are shaping how you can actually get to the goal. And in this case, the paths that we draw here is one of the solutions, not the only one of the solutions that gets you there actually.
So, yeah, 1 million times over without ever doing the same thing, same way twice.
So we were just drawing one solution, of course. And a pattern means you want to have many, many solutions. And what we see here is, of course, if somebody is walking along that path, it's always a different hike. But it looks very similar. And we're actually creating a solution space. These are all the different paths that you can actually draw.
That's a possible area for those paths without killing yourself. Yeah.
Without killing yourself. So it's actually, sometimes it's not that bad if you make one wrong step. At other points, you have to be really careful in the implementation, because one step into the canyon, not a good idea.
We fall off the stage here, yeah. And so we have a good enough model here.
Yeah, so another way of representing that pattern is to pick a one model
Yep.
right? Just one exemplar to show what works. But what you actually want to do is, how do I get there? This drawing is nice, but you want to know which steps do I have to do? And what you should write down if you have that solution is you should provide the essential steps.
But I'm not going to write every step for the path, right? Because that would be like the map is the territory, right? That's really
And the problem
impossible.
is, if a tree is falling down and I just provide you a step-by-step instruction, well, you're stuck once there's a tree in the path. So you have to rely on your, that's your word, heuristics, on your knowledge. But the question is how much, well, you see, we're not providing all of the details, but the question is how much detail do we have to provide? If we take away too much, we abstract too much, well, we're losing the shame. You can't see the solution anymore. So we have to be careful what to take away.
So my point is like, man, writing a really good pattern description that works for experts and non-experts alike is really, really hard. Yeah. And a goal if you have a pattern description is really to give you the points of the essential steps, but you got to fill in good enough that you can adapt. A lot of work.
And of course, if you're looking for a path that could lead you to the goal, you have to find a path that actually fits into the context. And this is another book written by Christopher Alexander in the 60s, in 1964. So actually, his idea of pattern goes back a long time. And what he says there is a fitness between context and form. And the form is the solution, actually, to the problem that we have in the context. And what you see there, well, the green form is our solution, and it fits to different degrees to different contexts. So on the right-hand side, it's the ideal fit we're looking for. We're trying to achieve that iteratively, step by step. But what we can also see, sometimes we don't have that perfect fit. And also, the context may change.
Will change.
It will change. So there's new technology. So technology changes the context. So that means if you change the context, the fitness might not be as good anymore. And that applies to patterns as well. Patterns that were written 20 years ago.
Software patterns, that is.
Software patterns.
Not elephants, yeah.
They're a bit more stable.
You think? What about climate and climate change and things like that? So the point is, you have to fit something through a context. So if I'm having a pattern, I should have enough freedom to fit to the context. And if the context radically changes, or any context I have is unique, really, is a unique thing. So there's a lot of judgment required. So I think that heuristics kind of help you out. Your personal heuristics, your design heuristics that you have learned through your experience. And so we've been talking about patterns and heuristics separately, but how do they work together?
So actually, I think that each pattern is in itself, usually a complex heuristic. It's not like a real law. Christopher Alexander sees it different, maybe he calls them laws sometimes, but actually it's like, it's almost like a law. In a certain situation X, you have problem Y, and pattern set or solution set can actually solve that. And the reason why it can solve that is that we have a problem that consists of several forces. And forces can be actually many, many different things. It can be a testable law. So for example, the more objects you create, the more memory you use. Well, you can test that. That's always true. It can be a constraint. How many people, how many developers are on your team? How many resources do you have? How fast should your algorithm be? It can be values, norms that you have to obey or you have to think about. And they can, of course, also be heuristics.
And I suspect there are other sort of forces that are driving us as we're designers. So each solution that we create has to have specific steps, right? And abstractions, but there will be gaps. And as we design, we're filling it in with little tiny things that we're doing, our heuristics, to fill in the gaps. We just have to do that. We're makers. One thing I've been thinking about is why do I like my code better than I like your code, right? Because my heuristics are mine, and if I don't understand yours, there's the fit, my model to your fit is something that I have to understand. But still,
and there's always this discussion: how much should we put into a pattern description? And of course, that we can always do more and more research when a pattern works and when it doesn't work. But it's actually, you don't want to put everything in it. You want the actual designers who use the pattern fill in the gaps and make the decisions and the judgments. So it's not just a template that you can take and apply.
So, just thinking about observer, you think observer. I've implemented observers several times, and we were having this discussion about all the things I needed to know when I first did my small talk observers and made things wrong. I have to have heuristics that when should I notify when a state change happens? You might think everything. Not always. So I had some heuristics about the kinds of its attributes or information or behavioral changes were important to notify. Not all of them are. And some on the other hand, handling if you expect the whole operation of the system to work that you're building, there might be an indeterminate number of observers. And then, of course, there are heuristics for if I'm observing how I respond to an update, because if I change that subject while it's still notifying other observers, then I can get this jittery feedback loop until it settles down, or it can even build infinite loops. That was fun. But so I learned all these things. Do your students know these, when you...
I don't teach that for a good reason, because you have to learn these problems by yourself. So if I just say, this is the solution, then I come up with all the problems that can happen then. Oh, nobody understands the problem that are the consequences of the pattern. So what you have to do is you have to really implement this thing, and you have to feel the pain.
Yeah, I was going to say,
what's going on.
I want a T-shirt now with.
And then you have to
Zlotyk's pain function here. You have to learn heuristics. You have to feel some pain and discovery and walk that path.
And then you come up with your experience, how you solve these kind of things.
So. When I think about really understanding, sometimes it's intuition. I go with where I'm going, and I observe what's happening as I'm doing something, and I'm internalizing some heuristics that I found, even if I may not be aware of it. I probably could rattle off of quite a few more heuristics I had about my favorite stories about implementation of observers and subjects. And then I would go to a new framework or somewhere else, and I might have to learn a whole new set of tricks that what they did, because modern ones may cache things and do some ordering of listeners and all this. All frameworks hide details that maybe I should know anyway. But we'll move on here.
So then, how do we communicate the knowledge? We were talking about, what should we leave out? What should we put in? And how can we actually share what we know already about designs? And, we can invent new things, or we can look into things that have already worked in the past. So, if you want to describe something, you have to generalize in a way. And you come from the specific, and you try to generalize and express what's, not abstracting, but actually, what is working generally. And what you have to do is you have to select good examples and compare them, and you have to think what is a good way of showing that.
Oh, we've been talking too theoretically. Let's get back to elephants, please. Yeah.
So what we can do is we just show elephants, and you can learn from showing elephants, different elephants, how they look like, and showing them from different perspectives. And another way of doing that is what we just saw in the quote, is we can compare elephants to other things. And we can do that with designs as well. Not just showing one design, but many different designs that are variations of the same thing, and comparing that to other designs.
Then we come to illustrating.
Which is also helpful in one way, because it is showing the essence, but
Chris,
Well,
what color is that elephant?
yeah, that's, if you only show me that kind of elephants, I wouldn't know that they are gray. So that, of course, this information
Does this
is
help?
taken away. No, doesn't help, but it provides you more views, more angles, more perspectives, so you can learn more about it. And of course, there are other ways. So this picture I've taken last year in the Natural History Museum in London, and I was, of course, we always see patterns everywhere. You see heuristics everywhere.
And elephants
And
now.
now we see patterns elephants everywhere. Well, that's nice, it's good. So I was seeing these in the museum, and they were real size scaled. So you can really get a feeling of how do they compare to other animals. You can take your own perspectives and explore. So this is really great. And in the museum, they also have this nice model where you can actually experience how the legs of an elephant function. So they compare that to the legs of horses. A leg has, if you have a horse, it has a knee, so they can run very fast. Elephants don't have that because they have to carry all that weight. And you can play around with that, with just pushing that. And what you don't feel what an elephant feels, but you
So
get
what
a
am I
better
pushing
understanding.
Here? I'm pushing on
You're pushing on top of
these
that,
artificial legs.
and you see how the weight is distributed. So it's really giving you a better understanding than just watching them, even in the wild.
Cool, I wish I could do that with software. So, but also in elephants, you can observe them in it. Like at the Portland Zoo, I took this photo of the Portland Zoo. You know, they want to make sure that their elephants are having fun, so they put different things in there and see how they play. And they give them pumpkins on Halloween because they're vegetarians. And anyway, so you know, observations of them doing things in that context is kind of getting to know a little bit about them and their individual personalities, actually. But then you can also look at elephants, and this was again in the zoo, historical things, because the Portland Zoo is actually caring about elephants over time. They had captive breeding programs. They're worried about their safety in survivalship in the wild, so they gave a very good, so you can do that kind of research. And then
There are also views that are not so helpful. So these are proper elephants, but if you want to introduce the concept of an elephant to somebody else, it's not the best idea to start with that. Neither with the elephant that we see from the back, nor the one where we just see part of it. Well, they're elephants, but you can use, they're not that useful. And even worse, there can be misleading views, like these comics elephants. And, well, you don't learn about elephants they're cute, but they are not good for learning about
sometimes
elephants.
I think, and I hadn't thought of this, but I'm going to riff off of this thought I had. Head first design patterns had that impression to me of misleading elephants, but now I'll leave that.
But there are also misleading views in other fields. So, for example, if I want to explain what an observer is, I could use that metaphor, but maybe it's not the best way to show what an observer is. I mean, yes, you're observing something, but all the mechanism of registration and how you abstract things, it's not in here. So it's not the best way. It can be actually misleading if you use this kind of pictures.
So was observer misnamed? Okay.
I was wondering that. I didn't want to bring that up.
Oh, we can. So another thing that's interesting is you can look at speculative ancestral views of elephants. You know, not just the history over recent time, but you can, you know, these are artistically reconstructed renderings. They're actually pretty cool. And if I could read them, you know, Stegotetrabelodon is an awesome elephant prototype, which has dual tusks, you know. And then there's the Platybelodon that has this shovel mouth. And so I can learn something from way long ancestral views. And then currently in our world, elephants are like this. But which kind of leads me to think that the very first time that patterns were written down was their first attempt at observing them. So things have moved along, and I know in the DDD community, some people have said, well, some of these are more important than others, but I would imagine, we have books now in functional programming patterns. Different forms of these patterns are appearing, and design patterns may be proto-patterns, and some of them should have been extinct, like I wish the singleton would have died. But anyway, so it's interesting to me that this is from Ward Cunningham's C2 wiki, where a lot of the pattern discussion went on in the early days. He shut down because of spam, like in 2009. I found this quote by Todd here, that and this was in 2004 that he wrote this quote, I think. I'm starting to think that most of what we call patterns are really proto-patterns. And they may have been used dozens of times, but are still suspect. I suspect that the forms have evolved, because we've had our discussion personally. But anyway, what he said is he tended to have more faith in organizational patterns. Yeah, it's probably something he didn't really know about. I'm guessing because I think organizational patterns have changed too. So people have observed this even in the early time. It's like, what we're seeing is different.
So patterns certainly evolve in some way. So what do we see, what did we saw in this talk? We have different kinds of patterns we're talking about. There are, of course, well, I see it that way, patterns in the world. That's a reality. There's an infinite number of recurrent structures that are observable. But these are not the ones we are writing down. There's actually something that happens before that, and that's actually how we build the patterns in our heads. And we kind of filter all the things that are happening. We just look for these recurrent structures, the patterns that are meaningful to us. And we have them stored in our heads as schemata or even heuristics, or a combination of that, and we think, well, this is how things are going on. And then we sit down and write down the patterns.
Some of us do.
Some of us do. And these pattern descriptions are somewhat like local theories. They're not universal, but they apply to the specific context that we have defined for that pattern. And there's a lot of things in there, forces, and we can test these forces, whether they actually are there. We can even test whether the solution works in that specific context. So that's what we write down. It's testable, and what is most important, other people can do the same thing, hopefully, if we write them in a good way. So from the pattern descriptions, we can come to more patterns in the world.
It's interesting, when you think about the historical stuff that we've talked about, that these pattern descriptions were almost like our understanding of a pattern author at a point in time with our observations, with people critiquing it if we went to pattern workshops with their experience, and we said, here, go implement it, right? Yeah. And it's amazing that people have done a lot. But I think the other thing, too, is there's a lot of strength going on here where I'm doing reality and mentally making these patterns and schemas.
I think the circle we saw before is a bit cheating because it's not that straight, as we always like to do in models, like saying, well, yes, there are patterns in the world, they're in my head, and then I write them down. What actually is happening most of the time, unfortunately, we don't write them down. So it's just, we build the patterns in our heads and then we just apply them personally. So this is our own personal patterns. And what we know about them, can we go back one time?
Yeah, sure.
So what we know about them is actually shaping also the world. And another important thing is the moment when we write down the patterns, we are starting a reflection process. We're thinking about, is that really a good solution? Does it really fit in? And that is really helpful.
Well, so even if we learned about a pattern from a book, and we did this loop, I'm going to make a thing, every time we implemented 1 million times over in our head, we're not copying, we're adapting to our context. So really the pattern in our head is different than that pattern in the book.
Absolutely.
And as we said, most of the patterns that are out there have not been written about. Everybody isn't an author. It's a hard, lonely job sometimes to write patterns. It's very reflective.
And Christopher Alexander says patterns are only alive to that extent as they are in your head, as the person who uses the patterns.
But we want to communicate them to others.
That's right. So you have to communicate them in a way so that other people can actually build the patterns in their head.
So Alexander, just before we go in and close, had his patterns, and he did an experiment where he said, oh, people, use the patterns, build your houses. And his reaction to that was he's pretty unhappy.
Yes, that happens to me also sometimes with software patterns. I give them out to other people, and what they do with them, well, it doesn't make me always happy.
Because their understanding, even if you gave the essential steps, is different than yours.
Yeah, so it's not an automatic win if you use the patterns. You have to actually use your heuristics, add them, and only then you can actually build something that is alive. So, to come to conclusions, well, if we talk about patterns, we generalize, we think in generalities, but then when we use them and we create something new in the world, we have to take care of the details because we live in the details, and we have to think about how can we actually create these things in the world.
So, want some takeaways from this talk to think about. Knowing is not really knowing. Knowing is not fully understanding, and I don't know if I think that's possible. And knowing is not enough to build something. A real downer, right? But
patterns can help.
Yeah.
They help to communicate knowledge on a specific level of abstraction, but they require you also to think, and that's why.
Yeah, I think the bottom line here is heuristics might help even more. And being aware that we as designers and makers need to be aware that we don't just copy and paste patterns. I think people wanted to do that. They hoped for that. They hoped patterns would tell them the essential steps, but I think it's really hard. So we have to be aware of our fit, of our solution, our pattern in our world, our software, and be aware of its fit and keep applying heuristics and sharing them, I hope. So with that, we hope you stay curious. We wrote an essay that you might find interesting to read, and keep in touch and share with us your heuristics and patterns. Thank you.
Thank you.